Hello guys, in today's lesson on physics calculation, we're going to continue the great job we started on two-dimensional motion. In our previous lessons on two-dimensional motion, we discussed the types of two-dimensional motion, which are the projectile motion, the circular motion, and the simple harmonic motion. Now we perfected everything on what we call the projectile motion, and today we're going to be discussing the circular motion. So what's a circular motion? Now look at a circular motion. A circular motion is a type of two-dimensional motion. When we talk about two-dimensional motion, we can also call it angular motion. Don't forget that the reason why we call it two-dimensional motion is simply the fact that the body or bodies undergoing this kind of motion move in both x-axis and y-axis. So it's a type of two-dimensional motion which involves bodies moving in a circular path. Now we all know what a circle is. When we talk about a circle, this is what a circle is. So when we have bodies moving in a circular path, either about an axis or when we have a body moving in a circular path, we call it. We can say that body is undergoing what we call circular motion. So circular motion is quite a broad and complex and kind of motion. So we're going to be discussing everything about it. But today we're just going to be looking at introduction into circular motion. We are not doing any calculation on circular motion today. So we're talking about circular motion. What are the parameters? What are the concept, the certain things we use or we mention when it comes to circular motion? So we have different concepts, or I can also call it parameters under circular motion. So we have concepts such as this. Under circular motion, we have the concept we have, the parameters we have. Under circular motion, we're going to be discussing speed. We're going to be discussing velocity. We're going to be discussing acceleration. We're going to be discussing speed, velocity, acceleration. We're also going to be discussing, we're going to be discussing force, stroke tension, and also we're also going to be discussing energy. Probably you're going to be discussing energy also. So these are the terms we're going to be using when it comes to circular motion. So you're going to be discussing speed, velocity, acceleration, force or tension, and energy. But today we are not going, as I said, into calculation. We're just going to be looking at the basic concept of circular motion. So what are the types of circular motion? What are the types of circular motion? Now, circular motion is divided into various types based on two major methods of categorization. So these are the method of categorizing circular motion. The first method of categorizing them is what we categorize circular motion based on position of travel. That's the first. The next, we categorize circular motion into various types based on axis of travel. First of all, based on position of travel. Then the next is axis of travel. Now, what are the types of circular motion that we have? What are the types of circular motion based on position of travel? Now, based on position of travel, we have what we call the uniform circular motion. The uniform circular motion based on position of travel. And also we have a non-uniform circular motion. These are the types of circular motion that we have based on the position of travel. Don't forget we are discussing the types of circular motion. And also the next is based on axis of travel. Now based on axis of travel, we have the x-axis. We can classify circular motion based on x-axis of travel, which we call the horizontal circular motion. Horizontal circular motion. And also the y-axis, which we call the vertical circular motion. So we're going to just quickly be discussing each of those types of circular motion. We're going to be seeing the difference between them. We're going to see the difference between the uniform circular motion and the non-uniform circular motion, and also the horizontal circular motion and the vertical circular motion. In our next set of lessons, we're going to be deriving various formulas and we're going to be solving questions on them. So what is about uniform circular motion? Don't forget that we are discussing circular motion. Circular motion is a kind of motion whereby bodies move in a circular path. We discussed that already. It's a two-dimensional kind of motion. It's a kind of motion whereby bodies cover distance along x-axis and y-axis simultaneously. So let us see what are uniform circular motion and non-uniform circular motion. Now, when we say a body moving is moving in a uniform circular motion and a body moving is moving in a non-uniform circular motion. Now, the uniform circular motion is a kind of circular motion, that is very simple. Let me use that word. Now, from the name uniform, uniform simply means there is equity. Uniform simply means there is regularity. Let me use that word. So when it says uniform circular motion, we are talking about a kind of a circular motion that doesn't easily change. It's simple, it's basic. But when we talk about non-uniform circular motion, as you can see, non-uniform, it means there's no equity. It's a kind of circular motion whereby the body, even undergoing it, takes different position. The body is takes up different position and is quite very complex. So that is that for uniform and non-uniform circular motion. That's just a simple explanation for that. So quickly, let's see the major differences between them: uniform circular motion and the non-uniform circular motion. So let us see the differences between them. So let's look at different aspects. So let's quickly discuss this. Look at different aspects. So the first aspect we have, the first aspect. Now the uniform circular motion, UCM, let me just call it that, and the non-uniform circular motion, NUCM. Now, number one, based on complexity, let's discuss complexity first. Now, based on complexity, the uniform circular motion is very simple. It's very simple. We call it uniform because of the fact that it is simple, because of the simplicity. Now, the non-uniform circular motion is very complex. It's a complex circular motion. Don't forget, we are discussing bodies moving in a circular path. So when we talk about simple circular motion, we have examples such as Ferris wheel. We have Ferris wheel, for example. We have, for example, a ceiling fan, the blades of a ceiling fan, blades of a fan. Just give you an example, for us to see how simple, the uniform circular motion is. We have a Ferris wheel, we have blades of the fan, of the ceiling fan. We have even what they calling it. We have different examples actually. We may not be time to state them all out. Now we have satellites, orbiting the Earth, orbiting the Earth. We have different kind of examples. We have many other examples, even the wheel of a car, the way it moves, and so on and so forth. We also have an example such as, let's say, a ball, or let's say a pendulum bob being tied to a string and being rolled around like this. So we have different kind of examples under the uniform circular motion. Now, one thing I want to take note of is that they are very simple. They are not complex. They are very, very easy. They are not complex. They are simple. The Ferris wheel, you know what the Ferris wheel is? When you go to major parks and the rest, amusement parks and the rest, you see the Ferris wheel, a kind of circular big ring like this where we have seats and so on and so forth. You know, so the thing rotates and it's a Ferris wheel here. So Ferris wheel is just, or like the blade of a fan, the blade of a ceiling fan or any kind of fan. As you can see, you see the way it moves. It maintains just that uniformity. It's just the way the thing moves, and that's how we call it uniform. It just goes like this, like this, like this. So it's a simple kind of circular motion. So when we talk about complex, when we talk about a non-uniform circular motion, now the reason why we call them non-uniform circular motion is simply because of the fact that they are complex. They are not uniform. For example, we have a roller coaster. Roller coaster. Roller coaster is a very good one. Then we have a pendulum. Pendulum moving in a kind of circular arc. Also, we have a kite. Let's say a kite being blown by the wind. A kite being blown randomly. And when we look at, we have other examples like that. Now, the reason why we say they are complex is simply for the fact that their path of movement, their position of movement, that is when they move in a circular manner, their position of movement is very complex. They take up different position. Now, when you look at a roller coaster, I can't draw a roller coaster. I probably on the board. I can't sketch it. But you know what a roller coaster is? You see, just almost like a Ferris wheel, but it's different. You see, bodies taking different position. You know, at the point it's at the top, at the point it's at the bottom. Different kind of movements, complex movement. Now, a pendulum bob also. When you look at the pendulum bob, for example, I think the pendulum bob is easier. You can see the pendulum bob somewhere around here at a point, somewhere around there at a point. So it just goes like this, oscillates. At the point, at this very point, you can see the kinetic energy here is zero, potential energy is very high. At the very middle, kinetic energy is very high, is maximum, while potential energy is not maximum, is zero. So there's a kind of complex movement. Although this body moves in a circular arc like this, but the whole movement is complex. That's the difference between uniform circular motion and non-uniform. Uniform in the sense that the same pattern of movement, like a ceiling fan, the blade just keeps moving. Why this is not uniform? Because of the fact that the body moving takes different position. It's at this position now, and the next few seconds or minutes is at another position. That's the first difference between them based on complexity. Now, the next difference we're going to be looking at is speed. Now, when you look at the uniform circular motion, a uniform circular motion has what kind of speed? It has a constant speed. The speed is constant. Now, when it comes to circular motion, as I said, we have different parameters. We have speed, we have velocity, we have acceleration. Now, don't forget, speed is a scalar quantity. Speed is a scalar quantity. Velocity is a vector quantity. Now, the kind of velocity we have under circular motion, we can say we have two types of velocity under the circular motion. Velocity is vector because of the fact that we have both magnitude and direction. But speed is just magnitude. We don't have direction. So for velocity, we have two types of velocity under circular motion. We have angular velocity, and we have they also call the angular velocity the centripetal velocity. Let me use the word centripetal. That is angular. And we also have what we call the linear velocity or the tangential velocity. So velocity under circular motion is two types. We have angular and we have linear. But for since speed is a scalar quantity. There's something like angular speed, linear speed. Whenever you see angular speed, that means you're talking about velocity really, because speed is a scalar quantity. You don't really care about the direction, in which the body moves in. So acceleration also, we also have what we call angular acceleration and linear acceleration under circular motion, and that just that. So you're going to be looking at other things. So the next difference between uniform and non-uniform is the speed is constant for uniform, while for non-uniform speed is not constant. Now the speed is either increasing or decreasing. The speed is not constant for non-uniform circular motion, but for uniform circular motion, the speed is constant. We're going to be looking at that. Don't forget the major examples, the major differences. The uniform circular motion is very, very simple. It's very simple because of the fact that the bodies undergoing them maintain a perfect path, a perfect position. Just the same path, the same position kind of movement be repeated. But this one, bodies, like for example, a kite now. A kite that is being blown by a wind in the circular format, it takes irregular positions and so on and so forth. And that's why it is complex and under the non-uniform circular motion. So the next we're going to be looking at is velocity. So the velocity, when it comes to velocity, under the uniform circular motion, the velocity is the magnitude of the velocity, magnitude is constant. Let me just do this to differentiate them. Magnitude is constant. Magnitude is constant. Magnitude is constant, but direction changes. Magnitude is constant, but direction, there's a change in direction. Now that's that for uniform circular motion. And when we look at a uniform circular motion, apart from the fact that the speed is constant, don't forget what the speed is. When we talk about speed, speed is a scalar quantity. Speed is distance traveled over time. When we talk about speed, the distance traveled over time taken. So for a circular motion, the distance traveled, per time taken for uniform circular motion is always constant. What it means is that the speed does not change. As the body moves like this, the distance it covers, over time taken for uniform circular motion, this is just for uniform circular motion, does not change. Unlike the non-uniform circular motion, whereby the body takes different position. The body is here now, the body is at the other side, and so for the non-uniform circular motion, the speed is not constant. The speed could either be increasing, for example, a roller coaster, at the very top, the speed is very little. The speed is minimum. Why when it gets to as it descends, the speed becomes very high because gravity is pushing it down. So now we're talking about velocity. Now for circular motion, velocity does not change its magnitude, but there's always a change in direction for velocity. You're going to be seeing that, for example, you're going to see that, let's say, for example, we have there's a body at this position now, also later at this position A, position B. This is a this is a uniform circular motion I'm talking about. So let's say this ball is being weighed like this, it's being rolled like this. At this very point in time, you have a velocity at this point, another velocity at this point. Now the velocity here and velocity here, they are the same. You have the same velocity. But the fact is there's a change in direction, as you can see. It's facing here at this point, while it's also facing here at the other point. Now don't forget something. We have two types of velocity, as I said, under circular motion. We have two types of velocity. We have what we call the linear velocity. It's a linear velocity. That's what we call the angular velocity, just like this. So don't forget, we're talking about velocity here. Velocity is a vector quantity. So right here, this is a linear velocity here. We call it linear velocity or tangential velocity. You can see the body at those very points in time. This very body, the velocity A, faces this very direction. Then at this very point B, the same body faces this direction. Why angular velocity is just now there's a major difference between the linear velocity and angular velocity. The linear velocity is mainly concerned about the angular velocity is mainly concerned about the angle that is the axis of movement. This mainly cares about how the body moves, the angular movement involved in this whole thing. But this very velocity here simply talks about the speed of the body at different tangents. And when we talk about tangents, we're talking about, as you can see, this is a tangent. This line here, forms a kind of angle 90 with this very ball or with this very object moving in the circular path. So this one really talks about the speed of this very body at various edges, at this edge A and this edge B. But this angular velocity here, which is with this symbol omega, it mainly talks about the angular speed, the angular, distance, the angular, speed. Let me use that word. This talks about this. What it talks about. So that's that for that. So when it comes to complexity, uniform circular motion is simple. Why this is complex? When it comes to speed, the speed is constant. Speed is not constant. Velocity, the magnitude is the same. The velocity, the size of the velocity does not change, but direction changes. Now, when it comes to non-uniform circular motion, both both direction, both direction and magnitude, both direction and magnitude change. Not changes. That's a plural verb. Both direction and magnitude change. So there's a change in both direction and magnitude of velocity. Now, don't forget, there's a big difference between speed and velocity here. I'm very sure we understand what we're talking about here. The speed is scalar. You know what the speed is. When we talk about speed, speed is just the distance all through this. As you can see, the distance just all through this circular path. That's the speed we're talking about here. So the speed is constant because of the fact that this body moves in a uniform circular path, just like this Ferris wheel. Unlike a kite, unlike a roller coaster, whereby there is no regularity with the movement. The body moves, in an unpredictable manner. Let me use that word. And that's why it's a non-uniform circular motion. So we're done with complexity, speed, velocity. The next we're going to talk about is acceleration. Let's see further difference in acceleration. Now, when it comes to acceleration, let's just talk about that here. When it comes to acceleration, now for uniform circular motion, we only have what we call centripetal acceleration. We only have centripetal acceleration for uniform circular motion. There is no tangential. Don't forget, we said when it comes to circular motion, we have linear or tangential. The linear portion is the same thing as tangential, as you can see. This is linear. Linear simply means it's moving in a straight line. It's same thing as tangent. Linear speed, linear velocity, I beg your pardon, or tangential, velocity. Now, not only that, we also have what we call angular. So the same thing with acceleration. We have linear acceleration or tangential acceleration, and we also have what we call angular acceleration. So it's the same thing. We don't have that for speed because speed is scalar quantity. Speed has no business with direction, just magnitude. So for acceleration under the uniform circular motion, now we only have centripetal acceleration, which is angular acceleration. Now, why is this so? Why this is so is simply this. Don't forget, acceleration is simply change in velocity over time taken. Now, for the fact that the speed is constant, speed does not change. The speed is constant. So if speed is constant, it means there won't be acceleration in that manner. If speed is constant, acceleration is changing, changing velocity or changing speed over time taken. Now, velocity here, the velocity, is the velocity changes. Let me use that word. Velocity changes, yes, because of the fact, even though the magnitude is the same thing, but the direction changes. So you can see there's a change in velocity in this second portion, this velocity. Now, for the fact that we have this acceleration here, the only acceleration we have is angular acceleration, which is centripetal acceleration. That is for uniform circular motion. Now, the reason why we don't have tangential acceleration is because of the fact that the speed, which will have brought about tangential acceleration, is constant. The speed does not change. So if there's no change in speed, it means there will not be change. It means there will not be acceleration. Because acceleration is change in speed or velocity over time taken. So what we just have here is only angular or centripetal acceleration. Only angular acceleration or centripetal acceleration. While here angular, we have both angular and linear. Linear is written as tangential acceleration. We have both angular and linear acceleration. That's what we have for this very portion. Now, for non-uniform circular motion, we have both of them. We have both angular acceleration and we have a linear or tangential acceleration. This has only angular acceleration because it is only velocity, and this velocity could either be angular velocity, merely angular velocity, or linear velocity. So that's just that. Why the speed here is constant. Speed here does not change really. So let us look at one more difference in aspect. So we're going to be taking off this portion. Let's look at one more difference in aspect between uniform circular motion and non-uniform circular motion. So this is what we have. Now, for the uniform circular motion, we are saying there's an aspect here, and we have UCM and NUCM, non-uniform. So here, on that kinetic energy, that's KE. Right here, now due to the fact that we have a constant speed here, it means you have a constant kinetic energy. That's what it means. Right here we have a changing kinetic energy. So we have a couple of more differences between them. So we're stopping here at those area points for uniform circular motion and non-uniform circular motion. So from here we're going to be moving on directly to the horizontal and the vertical circular motion. So let's see the differences between horizontal and the vertical circular motion. Let's quickly discuss that. Let's look at the differences between the horizontal and the vertical circular motion. Let's see the differences between them, horizontal and vertical. So what are the differences between horizontal and vertical circular motion? So horizontal and vertical is horizontal under the same aspect, and this vertical. So let's look at the differences between them, horizontal and vertical. Now, when we talk about horizontal circular motion, horizontal circular motion looks very much like the uniform circular motion. It is very simple. The vertical circular motion looks very much like the non-uniform circular motion. Just share a couple of things in common. So when we talk about horizontal circular motion, what does it mean? Horizontal circular motion simply means, don't forget we are discussing classification of circular motion based on axis. Now, this horizontal circular motion is based on x-axis, while this is based on y-axis. So, for example, let us see what it looks like. Now, for horizontal circular motion, let's say okay, let me just use this. So we have this right here. And let's say a ball is being weighed like this. In a horizontal format, let's use this. A ball is being weighed like this. So there's a ball. Don't forget there's a length, this is a string, and there's a ball here. And this stuff is just like this. It's a radius. It's an angle of movement. So this stuff moves horizontally like this. So we talk about horizontal circular motion, we're talking about bodies moving in a circular horizontal like this. Now the movement is parallel to the ground, as you can see. And also gravity, acts in such a way that is parallel to this movement, to the path this very object is moving in. So it's moving like this. This is horizontal. How we talk about a vertical? The vertical means the body, the body isn't weird like this. This is vertical here. So I have a rope and I'm doing it like this. That's vertical. Horizontal, it's like this. That's a big difference between them. So now what are the differences between them? Now the first, when it comes to this, the first aspect is simply this. When it comes to simplicity, let's look at simplicity also. When it comes to simplicity, the horizontal movement is very simple, very easy. This is complex. This is very simple, this is very complex. This is complex, this is simple. That's the first aspect you're going to be looking at. That's aspect one. Then the second aspect you're going to be looking at is simply this, the effect of gravity. Let's see what gravity does here. Now, gravity acts parallelly. Let me use that word, parallelly. Gravity acts in a parallel direction. Let me just write that. Gravity acts in a parallel, acts in a parallel direction, acts in a parallel direction to the movement. Why for the vertical acts in a perpendicular, acts in a perpendicular direction to the movement. That's a big difference between the uniform circular motion and the non-uniform circular motion as per the effect of gravity. Now, since gravity acts parallelly to this in a parallel direction and it acts in perpendicular direction, let's see the next different aspect. So the next different aspect is simply this effect. Let's see the effect. Gravity has no say, has no impact here. Gravity does not affect horizontal motion. As this thing moves like this, there's no business with gravity. And we're going to be deriving formulas for them in the next lesson. So you have this weight here, the weight of this bulb, and then we have a tension, this length of the rope, we have a tension in two dimensions, tension along the y-axis and tension along the x-axis. So there is no effect of gravity in this movement. Why? Because there's no acceleration. This body is not moving vertically. The body is just moving like this. So for the fact that the body is moving like this, gravity is just acting in a very less effective manner to this whole kind of movement. So gravity has no business with this. So how will I call it? The major quantity that helps this body to stay in motion is not gravity. It's merely tension. The tension from the string, and let me say friction, tension and friction. Gravity has no stay here, has no say here. So gravity has no say, but only tension and only tension as tension in the rope or string or whatever, only tension and friction as I say. So gravity doesn't have any effect on this. Why for the vertical kind of motion as the body moves in a vertical, let me say like this, the body moves, let's say an object, a bulb, this time around is being rolled like this. So at this very top, you have the effect at the top, you have the effect at the, at the bottom. You understand? So we have a different kind of speed at the top, varying, changing speed, and so on and so forth. So the fact is, this one, the vertical motion looks very much like the non-uniform circular motion, while this looks very much like it. They share a whole lot of things in common. So for this, gravity has a say. Gravity has a say alongside alongside uh, alongside tension. Alongside tension. So gravity has a say here. Unlike this, gravity doesn't have a say. So you have other differences. We have a couple of other differences, but we will not be able to take them. Even yourself kind of have the differences, a couple of other differences. The one major thing is this horizontal movement is very much the same. Shares a whole lot of stuff with the uniform circular motion, while the vertical circular motion is very much like the non-uniform circular motion. Also, we can also give one more difference between them. As you can see here, the speed here is constant. Speed here is constant, and here speed here is not constant. So very much like what we just mentioned. So these are the major types of circular motion and the differences between them. So in the next couple of lessons, we're going to be deriving all the formulas we need, both basic formulas and the complex formulas we need for calculation. So at this very point in time, we're drawing the curtain of today's lesson. If you found this lesson very resourceful, please subscribe to this very channel at Edgy Mosaic, and also follow me at Revelation Hub on Facebook. Please share this lesson also with others. See you in the next lesson. Thanks.